This is a video from eSkills Zone. For more videos, notes, and certificates, please visit www.eskillszone.com.
Hello and welcome. Hi viewers. Today in this video we will discuss a program which demonstrates several kinds of partial pies on the screen. In our previous video we discussed a program which demonstrates several kinds of partial circles on the screen, but today in this program we will discuss several kinds of partial pies. So let's switch to the IDE of GW Basic Programming Language. We will execute this program and see how it is done. So here we are, viewers. We will type a program and then we will type in line 10 RAM statement by typing all that asterisk which we used to mention in our previous programs. Line 20 we will type RAM and then asterisk, space asterisk, and then type PIES. And then once again typing the asterisk. Line 30 we'll type RAM and then asterisk, space asterisk, and then type demonstrates. The purpose of program we will declare over here. Just demonstrates several kinds of partial pies like that. Line 40 we'll type RAM statement once again, then type asterisk all the way along like that. And in line 50 we will type screen 1. Line 60 we will type color 1, 1. Line 70 we'll type RPD, radians per degree, equal to 0.0174532. This is how radians can be converted to degree. Line 80 circle 50, 30, 20, 3, minus 90, into RPD, minus 180 into RPD. Line 90 circle 100, 30, 20, 3, minus 180 into RPD, and then minus 90 into RPD. Line 100 circle 150, 30, 20, 3, 0 into RPD, minus 35 into RPD. Line 110 circle 200, 30, 20, 3, minus 360 into RPD, minus 35 into RPD. Line 120 circle 250, 30, comma 20, comma 3, comma minus 200 minus 20 into RPD, and then minus 200 into RPD. Line 130, circle 100, comma 110, comma 50, comma 3, comma minus 45 into RPD, comma minus 135 into RPD. Line 140, circle 200, comma 110, comma 50, comma 3, comma minus 100 into RPD, comma minus 80 into RPD. Line 150 and. So there is a mistake if you can see in line 120, because there should be a in line 110 there should be a comma mentioned right after 3, the value. So we'll press the enter key and name this program as, by pressing the F4 key, we'll name the program as PIES. So we'll type edit and then type 110, and then we'll give the value of comma right after 3, and over here we will type minus 360 into RPD, and then comma, and then minus 35 into RPD. And then by pressing the F4 key, we'll again type the name of the program as PIES. Now we can list this program. Here is the complete code. Now we'll press the F2 key and see the output. So here you can see that lots of PIES, several kinds of PIES on the screen. But line 100 makes a strange piece of pie. Only one edge of circle has a line drawn to the center. Basic will not allow a negative 0. So we have in line 100, we can see we have used a negative value, and negative 0 is not allowed. In line 100 we have used a value 0 in it. So you can see a strange piece of pie like this, but all the pies you can see always having a typical shape. So let's switch to the text area where we will discuss the execution, complete execution line by line of this program. So let's switch to the text area, viewers. So viewers, you can see this is the code of this particular program, which actually used to demonstrate several kinds of partial pies on the screen by using several circle statements having different starting and ending points, and the radius you can see always same, but here you can see the radius of line 130 and 40 having different radius and having the same color and having different x and y coordinates, but the values of the starting and ending points are different always, to demonstrate several kinds of partial pies of different sizes on the screen. So viewers, let's start the interpretation in line 10. RAM statement is used to display asterisk on the screen. Line 20, RAM statement is once again used to display the name of the program, PIES. In line 30, RAM statement is used to display the purpose of this program, which is to demonstrate several kinds of PIES, of partial PIES on the screen. In line 40, RAM statement is used to display asterisks on the screen. In line 50, screen 1 statement is used to execute this program in graphical mode. In line 60, color 1,1 statement is used to display the foreground and background color. In line 70, circle statement is used with line 70, RPD is assigned, used as a single precision variable is being assigned fractional value 0.0174532 by using assignment operator equal to symbol. In line 80, circle statement is used with x coordinate as $50 and y coordinate as 30 with radius 20, having color 3 and starting point -90 into RPD. And ending point -1 into RPD. Likewise, I'm copying and pasting all these lines. Like in line 90, circle statement is used with x coordinate as 100 and y coordinate as 30 with radius 20 having color 3, and the starting point is 0 into RPD and ending point is minus 35 into RPD. In line in line 90, the value of x coordinate is 100, y coordinate is 30 having radius 20 and 3, and the value of starting point is minus 180. So there is a correction needs to be addressed. Minus 1 into 80 into RPD, and then ending point is minus 90 into RPD. In line 90, correction has been made. And in line 100, here the circle statement is used with x coordinate as 150, y coordinate as 30 having radius 20 having color 3, and starting point as 0 into RPD and ending point as minus 35 into RPD. In line 110, viewers, circle statement is used with x coordinate as 200. You can always change the values to see different several types of partial pies on the screen by changing the values of starting and ending points of the circle statement. By changing the x and y coordinates, you can use multiple combination in order to see multiple different types and styles of partial pies on the screen. So I've used mine. You can use yours as 200 and y coordinate as 30 having with radius 20 and having color 3, and starting point as minus 360 into RPD and ending point as minus 35 into RPD. Line 120, circle statement is used with x coordinate as 250 and y coordinate as 30 with radius 20 having color 3, and starting point is minus 20 into RPD and ending point as minus 200 into RPD. Line 130, circle statement is used with the x coordinate as 100, y coordinate is 110 with radius 50 and having color 3, starting point as minus 45 into RPD and ending point as minus 135 into RPD. In line 140, circle statement is used with the x coordinate as 200 and y coordinate is 110, with radius 50, having color 3 in starting point, minus 100 into RPD and ending point as minus 180, minus 80 into RPD. So you can see in line 100, you can see a value 0 is used with RPD, which will quite strange value. You have never used 0 throughout the circle statement. So if you see, and we can address this as line 100 makes a strange piece of pie, only one edge of its circle has a line drawn on to the center. Basic will not allow a negative 0. So let's see if we change this value from 0 to some other value, like we have given multiple values as starting points, so we can give a different value, like we can give minus 20 instead of 0. So see what happens. So let's switch to the IDE. So we're gonna change, we have just changed the line 100, and we're gonna list this program by typing screen 9, most favorable screen for executing program in GW Basic. So we will list this program. So in line 100 we have just made a change, like I have replaced the value of 0 with minus 20 over here, and since when we have used 0 over here as a starting point with circle statement, we have seen an incomplete pi strange kind of pi, but now we have replaced the value of 0 with minus 20. Now I'm going to execute this program by pressing the F2 key. So we now can see this, that was the circle which was actually drawn at the third place. This was the circle drawn with the line 80 statement. This is with the line 90. This one was with 100, but now you can see a pi, a small pi, instead of an incomplete pi, because we have replaced the value of 0 with minus 20, and now you can see a pi on the screen. This pi is drawn with the help of the line 110. This one is with 110, 120, 130, and in the end 140. So you can see a Pac-Man, a vertical Pac-Man, with the help of line 140, which was the last statement. So this is how you can see several type of partial pies on the screen. That's all, viewers, and thanks for watching my video, and keep watching for more graphics videos in GW Basic Programming Language. That's all, thanks for watching.